Right, so welcome everyone to this webinar, which aims to provide some practical insights on controlling noise and which can help reduce costs by 80%, up to 80%. So this webinar feeds directly into a project we are working on at the moment. It's called Guidance Document on Guidance on Noise Reduction Options and Strategies in the Energy Industry. My name is Laszlo, and I'm a technical manager in energy transition, health and safety at the Energy Institute, and I'll be moderating this session today. So just a couple of, in just a couple of minutes, I'll be joined by Peter Wilson, Technical Director at the Industrial Noise and Vibration Center, who will give us a 40-minute or so presentation, which will be followed by a quick Q&A session. So before we start, just a few notes on housekeeping. The webinar is being recorded, and the recording and slides will be made available after the event. All participants will be muted except for the presenters. Please use the Q&A function for posting questions rather than the chat function, but feel free to introduce yourself. AI bots are not allowed in any form at the moment. So unfortunately, we'll need to kick them off if they appear in the meeting. So who are we, the Energy Institute? We are a chartered professional membership body for people who work across the world of energy. We are a registered charity with the Royal Charter and a long history dating back to 1914. We offer expert-led training courses, accreditation and professional development opportunities, including pathways to chartered engineer, environmentalist, and energy manager status. We have over 20,000 individual members and 200 partner organizations in about 120 countries. So all these members are working together with us to create a better energy future by accelerating a just energy transition to net zero. So our technical innovation department is working closely with these member organizations and external stakeholders. And with their support, we develop about 30 new standards and technical resources each year. These range from research reports to good practice guidance, workshop reports, and even animations. So they cover a wide range of topics across the energy transition, fuels handling, health, safety, and the environment. And so all that is to help enable industry to make energy lower carbon, safer, and more efficient.
Thanks, Laszlo. I'd first like to say thank you to the Energy Institute and Laszlo for organising this event. If I share my screen. Whoops. Let's get this the right way around. Okay. I hope you can all see that.
I can.
Yeah, we can see that.
Yeah. Okay. We're away. First of all, I'm the technical director at INVC. Our USP, if you like, is that we specialize in diagnosis and engineering noise control. So those are techniques and technologies that are separate from the conventional palliatives that most people regard when they think about noise control, such as enclosures, silencers, barriers, and such like. And I have to say that I am very disappointed with the noise control industry and the training that happens, because really the main problem with noise control is one of attitude. To use an analogy, imagine you're driving your car and you've got a rattle from the engine, and you take it to a garage, and without doing any diagnosis, they say, we need to change the engine and gearbox. That'll cost you $6,000. You do the diagnosis and you find out that it's a loose heat shield, and all you need is a new bolt. That is the situation as far as noise control is concerned. If you manufacture enclosures, all noise control problems are enclosures. And the other issue with noise control is that it's not a safety issue. People often regard it as a safety issue. It's an engineering problem. Identifying the risk is a safety issue. Solving it is an engineering problem that should be addressed using good engineering practices. The other issue is it's urgent for two reasons. One is health reasons. There's recent research showing that the risks posed by noise-induced hearing loss are dramatically more than anyone thought. And this has massive consequences. And the other thing is for environmental noise, this approach applies equally to environmental noise as well. In terms of environmental noise, there's also a massive health hazard because the chief medical officer in the UK has said that environmental noise is the second biggest environmental health risk after air pollution. People who live under the flight path, hospitals under the flight path to Heathrow, 24% more admissions for stroke than hospitals outside the flight path. It has a massive health implications, and this adds to the urgency. So what I'm going to do is to run through very quickly the ethos behind this project and what the aims are and what it's based on. The first thing is I've talked about the attitude and lack of knowledge about best practice, and it's a lack of diagnosis. It just doesn't happen. Noise consultants, even noise consultants, their knowledge of modern noise control diagnosis and technology is generally abysmal. It's disappointingly awful. And that is a big problem because that feeds into this attitude. And because of the attitude, you have assumptions about it'll be acoustic enclosures, high costs and hassles, maintenance, heat problems, and so on. I get asked to give talks to groups of engineers by health and safety officers and so on. And I walk into a room with 12 engineers sat around the table with their arms folded. And in their heads, it's this noise bloke is coming along here to make our lives difficult. Enclosures, cleaning, hygiene, maintenance, etc., etc. So this means that engineers on sites are reluctant to even consider noise control. And as a result, either they go down the conventional route and waste a fortune on things that aren't appropriate. Sometimes enclosures and barriers and silencers are appropriate, but often they're not. So they either waste a fortune on things that aren't best practice, or the problem gets ignored. And as a result, you have more risk, more noise-induced hearing loss, more claim costs, and more environmental noise complaints. Then the Energy Institute, we're going to be trying to address this by producing detailed guidance covering the industry. So it's the lack of knowledge is a disappointing thing. And what we're going to be trying to do is to transfer that knowledge in-house to organizations and companies so they can address their noise issues themselves to a large extent. And some of the things included and recommended as part of this process is reporting. Noise assessment reports, the general quality is awful. We are the major provider of noise and vibration training in the UK. We see more reports than anybody other than the HSE, and the general standard is truly dire. You need to have a high quality risk assessment benchmark report format that you use going forwards, whether it's internal measurements or external measurements. Secondly, real world PPE performance is nothing like people think it is. Virtually all risk management in noise is based on PPE. And assumptions 20 to 30 dB, because that's what the manufacturer tells you, you're more likely to get 3 to 10 dB in practice. So that's another issue. Carrying out a cost-benefit analysis based on diagnosis. Virtually nobody does that. And I'm going to be talking about examples of low-cost engineering diagnosis and technology that can be used. And we'll also be launching webinars to transfer this technology and this approach in-house. It's time to move into the 21st century because at the moment we're still working in almost Victorian technology. And there's massive amount of urgency because 700K hearing damage claim recently. This is set to become more commonplace. The HSE noise inspection focus, the 3 months have produced a 300% rise in enforcement notices. They are pushing because of new research showing how damaging noise-induced hearing loss can be. And PPE, the assumptions about PPE are just wrong. If you're much above 90 dBA, you are in trouble as far as guaranteeing adequate protection. And environmental noise complaints is a big health risk. It is policed, and the health implications are severe. And just to give you one case study, which I'll talk about briefly later, we did a project in the States for a big site, oil processing site. They had a quote $1.25 million for conventional noise control, and remotely over by email, we saved over $1 million by basing the approach on diagnosis and modern technology. And in some cases, you can actually improve efficiency and reduce running costs, which is a real novel idea. So I'm going to be talking about the driver for the urgency, and then diagnosing the options, engineering techniques, and case studies. So first off, and I have to state I've got a personal interest here because my father was an army officer and he had significant hearing damage. If you have severe hearing loss, you have got 5 times the risk of dementia. And my dad died of dementia caused by his hearing loss, almost certainly, when he was an officer in the army. Hearing loss is the primary modifiable cause of dementia. This is based on recent research. We have a tsunami of dementia cases coming down the line, and hearing loss is a major, major factor in that. And this is so depressing. I mean, my mum is currently dying of dementia as well. It is a horrible, horrible thing. And hearing loss is a major factor in this. This is based on recent research. Secondly, recent research also, hearing loss, 42% up to 42% higher risk of unemployment, 8% risk of earlier retirement, doubles your your likelihood of an accident. And this year in January, recent research has shown that for every 10 dB loss, which is almost undetectable using conventional audiometry, you have 57% increased risk of Parkinson's. And Parkinson's is the fastest growing neurological disorder. So that is dramatic, and it's all based on recent research. The second thing is that there's a new legal framework. And based on that, there was a recent court case, Ministry of Defense, and the judgment took into account not just the previous, the difference is that the previous legal framework said you're not allowed to include anybody who's being exposed below 85. Secondly, you based it all on pure tone audiometry. And thirdly, they didn't look at all the health risks. So due to the fact that recent research has dramatically increased the health risks that are specifically created by noise-induced hearing loss, you combine all those, and what the judgment said was, look, you should have known that your PPE was ineffective. The manufacturer's data was fine, but the real world data, you know, is much, much less. Currently, a part of 3M in the States is looking to have hearing damage claims of over 100 billion with a B dollars due to mis-selling of their earplugs into the armed services. That's absolutely massive. They must have known that the real world performance of PPE was a fraction of what they said it was. Plus, the judgment also took into account synapse damage. This is one of the problems, is that hearing damage causes dementia and Parkinson's and so on because a large parts of your brain are used in analyzing sound to understand speech, etc. So when that input goes down, parts of your brain start to atrophy, and that causes all sorts of other effects. And we're talking about all the other forms of health and disability arising. I've been talking to insurance companies, and they have all said, OMG, we're going to have to look at our policies because, you know, if settlements have gone for 5 to 50K up to 700 plus K, this is a massive 2 orders of magnitude shift. So these financial consequences are coming down the line rapidly. Also, pure tone audiometry is not best practice. It's a placebo thing, and the HSE recognize that. It's too late and not accurate. You need to switch to otoacoustic emission if you want to talk about that. I'm not an expert, but I have lots of links. You need to switch to that as soon as possible. The HSE inspection focus for the last year, the first 3 months, said a 300% increase in enforcement notices, all sorts of things. A lot of errors in noise reports. They're chasing down consultants now who are not doing best practice. And this is being pushed. All site visits by inspectors are now noise based, as well as everything else. And their research showed years ago that 60% of users of PPUs inadequate and 40% got no protection whatsoever. There's an HSE report checklist for noise reports and so on our website. It's not available on the HSE website as yet, but I'm part of the committee, so we put it up on our website. Looking at PPE, part of you get with this program is we have developed a real-world PPE performance calculator. These, you answer a few questions, in this case, muffs, attenuation, wear rates, fit training, safety glasses, etc. The manufacturer says 24 dB. In fact, you're probably getting 5 dB. So this will be part of the people participating in this. And fundamentally, earplugs are rarely fitted correctly. So you're assuming 15 to 30 dB, and the lowest 2 dB is common. Earmuffs, less variation in fit, but you're talking about 10 to 17 dB. And the wear rate should be 100%, but no one ever knows what the wear rate is accurately. And unless you know that, you're doomed. You have no idea the protection you're providing for people. What that means is, our rule of thumb is up to 90 dB, because you should have compulsory hearing protection between 80 to 85, as well as above 85. The regulations don't state that, but with the new legal framework, they're now including people exposed below 85. So best practice would be compulsory hearing protection at 80. As you go above 90, it gets very hard to guarantee protection. Above 95 dBA, extremely hard, and above 100, pretty well impossible without unbelievably strict conditions. There's an HSE video on this link, which will be provided as part of the post sending out this presentation. They're showing 5 to 6 dB attenuation under most conditions for an awful lot of common wear conditions. So looking at the process and the attitude, complicated. Some sites are incredibly complicated. And the key is diagnosis. Some of the diagnostic techniques that we use, first of all, narrowband frequency analysis. This should be standard, but isn't, for no apparent reason. I set up INVC 40 years ago. One of the first things we did was buy a narrowband frequency analyzer for diagnostic purposes. It cost the same as a car. You can now do the same with a free app. And there's information about one of the free apps available that we found works very well on our website. This is a necessary tool for anyone involved with noise. Third octaves are a waste of time. This allows you to be very, very precise about an awful lot of noise problems. We also use acoustic cameras, which can pick up noise sources remotely without having to climb a chimney. And there's also something that probably you don't know about. This is a normal video of a compressor. If you look here, you can just see this handle wobbling. This is enhanced vibration amplification from the same video. And you can see how everything is vibrating, and you can see the patterns of vibration. Another very useful diagnostic tool. There's massive misunderstanding associated with noise control. Hearing damage risk is directly proportional to noise dose, the amount of energy fed into your ears. Every time you double the energy, you double the risk. 3 dB increase in noise level is double the energy, therefore it is double the risk. An awful lot of people think that unless you can get the noise level below an 85 or 80, there's no point in doing anything, because you still have to wear hearing protection. But if you cut the noise from 97 to 94, you still have to wear hearing protection, but you have halved the risk. 6 dB off, 75% reduction in risk. 10 dB off, a 90% reduction in risk. So if you reduce it from 97 down to 87, you still need to wear hearing protection, but now your hearing protection will work, and you have reduced the risk by 90%. You document that, and the HSE will love you. And also, this is the assumption that it's not going to be practicable and all the cost because of abysmal lack of knowledge. This is one of the big elephants in the room. The other thing is, this is the hierarchy of control. All health and safety is based on this. This is what it should be. Noise control at the top, PPE at the bottom. For noise, it's reversed. PPE is all that's assumed in almost every case. And noise control is right at the bottom due to attitude. So our reports always have a noise control audit in there. Is this included in noise reports? Almost certainly no. It's unbelievably rare. The best you get in most noise reports about noise control is, wouldn't it be a nice idea if you could work out some way to reduce the noise? And you do need to use a high quality benchmark report format going forwards. If you carry out a noise control audit, which is a diagnostic evaluation of all the noise control options, engineering and the conventional palliatives, you come up with something like this. You have a return on investment. So you know what the noise control will cost and what the benefits would be in reduced risk, and you can compare that to the costs of your PPE risk reduction program. In this particular site, 6 years, and in red, we have cost of PPE. So after 6 years, it's 93K cumulative. For noise control, you're talking about a massively reduced cost, 40K. So the crossover point's 2.5 years. So the financial people would love this, 2.5 year return on investment. After that, we're in profit. But you need that information. You need to know what the options are based on best practice and what they would likely to cost and what the benefits would be. It's all return on investment. This is a real case study in the States showing you how lack of diagnosis causes dramatic problems. This cost Atlas Power $5 million on a completely wasted project on noise control due to a lack of a 5-minute diagnosis. I saw this video online.
The Atlas Power Data Center near Williston was granted a temporary 60-day certificate of occupancy last week after resolving several violations. Now, Williams County commissioners are watching closely to see if the company follows through on a promise to solve the excessive noise pollution in the area. Michael Anthony has more on this developing story.
Could the Judson Township finally get some peace and quiet out here? Well, Atlas Power has purchased several sound walls that should be installed sometime next week.
I analyzed the soundtrack on that video. 5 minutes later, I said, this is the blade pass frequency of the fans. That barrier cannot possibly work because it's a very low frequency noise, and the dBA is not the problem. So a lack of diagnostic capability or approach cost them $5 million plus a 232K fine for noise. Those are the consequences of not doing the diagnosis. So if you knew what was possible, what could you achieve? Did you know you can cut fan noise at source without silencers and increase fan efficiency in quite a lot of cases? There are also new metamaterial barriers. I've been involved in the development of these. These have got holes in them, which allow the air through, but not the noise. Extremely clever and very sophisticated, but very good for cooling, for example. Pneumatic noise, compressed air. You can get 90% reduction in air noise using 20% less compressed air. So why wouldn't you do that? You do that even if noise wasn't a problem because it saves on very expensive compressed air. You can also get everything proof, waterproof, acoustic absorbent, which is hygienic, weatherproof. We use that in pharmaceutical and confectionery industries as well as outside. So where you need to clean things, you can now do it. It's not just rock wool and fiberglass. And one of my favorites is sound damp steel laminate. So it looks like steel, sounds like rubber. So here's an example of that. This is rugged, it's cheap, and you can create it in situ or buy it off a company in Newcastle. So 20 to 30 dB reduction, it's hygienic, it's very easy to use, and it's very, very cheap. There are also knowledge about things that are available. Now, I may be very sad, but I love this next one. You'd think, is sellotape noisy? Well, if you've got a packing machine and you're pulling off sellotape from big rolls fast, you can get over 100 dBA. Now, the manufacturer was saying, install enclosures costing you 25 grand per machine. We came along and said, you can do this.
Okay.
I think whoever developed that, it was genius. You know, maybe I should get out more, but I think that's brilliant. And there are techniques like this, lagging around pipework, different forms of lagging that can't cause corrosion and also make inspection trivial. So there's all sorts of techniques and technologies. And the other thing is this exactly the same approach reduces carbon footprint. We call it the Greenpeace dividend. It's the same diagnostic approach. And what you're doing is you're swapping a bludgeon, such as an enclosure or a barrier or lagging, for a scalpel that says, what is the cause of the noise and can I fix that using engineering means? This cuts typical noise control projects by 50 to 80% cost. If you can get the noise low enough, you get rid of the waste from earplugs and muffs. Noise control structures, conventional ones, are large, using a lot of embodied carbon. The materials used, such as rock wool and fiberglass, not easily recycled. We generally try to recommend recycled PET bottles as acoustic absorbent and try to use as minimum as possible to minimize cost and to minimize carbon. And also, fitting something into enclosure probably means you need to add fans and cooling, which has increased running costs and reduced efficiency and more carbon. It's based on diagnosis and source control technology wherever possible. If you cannot do that, then you fall back on the conventional palliatives. So you're trying to cut embodied CO2. These engineering modifications are generally manufactured locally, so you lose the transportation costs. We're also doing an increasing proportion of our noise control projects virtually. We do this using smartphone technology all around the world, which is faster, reduces our carbon footprint, no travel costs, no flights, no nothing. We also do remote site visits using WhatsApp. And as I said, you can improve fan efficiency in some cases, and that reduces noise and running costs. Our current record is 22% reduction in cooling fan power consumption for the same cooling. Acoustic modeling, we do this, and a lot of organizations do this. This is an offshore rig installation model, saying what the noise level would be, predicting it in advance, and the same for environmental noise. The problem with most models is they're all based in terms of mitigation on only barriers and enclosures and silencers, not on engineering means. So they're very limited in scope in terms of mitigation. We also do things like CFD modeling to optimize cooling. This is a diesel generator set. Where do you put the fans? Can you reduce the size of the fans? Instead of having 4 fans, can you just have 2 fans? And this is from a data center where we're trying to work out what's the minimum amount of material for the maximum benefit that you can install to get the noise levels down. So a few examples of this approach in action. So this is a very large motor pump, and this is the sound file.
Okay, so this is the last one. This is the seawater pump. This is inside the hole on the last one.
So from that, we analyzed it to produce this plot. This is a 100 Hertz high frequency tooth comb, which means it's electromagnetic excitation of the thin metal structures on this. So just from one recording, 2 minutes later, we know what the cause is. You can then use vibration measurements on the panels to work out which panels are radiating. You rank them, and then you damp them in situ. You can do that while the machine is running, 10 to 15 dB noise reduction. Previously, they were thinking of putting up a big barrier or even an enclosure. Another example, this video, this is from solar farm inverters. Why are solar farms noisy? Well, transformers and inverters and fans. So traditionally, this is just tackled by people saying, okay, it's a black box. I have no idea why it's noisy. It's a black box. We'll stick an enclosure around it, or we'll put a load of barriers around it, both of which have implications as far as cooling. So you reduce the cooling efficiency, which means you have to run it harder and more power consumption. Simple diagnostics off that video. It's 340 Hertz and harmonics. It's the fan blade pass. This fan, you could design, we can design, we have designed retrofit modifications for that type of fan that have virtually zero cost if designed in. Retrospectively, it's more costly, but there's zero cost designed in and actually improve the fan efficiency by 3%. So it's a novel idea of noise control that actually improves efficiency. This is one off an alkylation plant. This is both an occupational and an environmental noise problem. So 100 dBA at 1 meter. So quick analysis, we have all these tones, 181 hertz, and a tooth comb. So you look at the details of the gearbox and you say, right, from that, it's like machine condition monitoring using noise. We said, it's a loose output pump output shaft. Repair that, and this was confirmed by vibration measurements, 10 dBA off the noise. It's quick, it's very, very accurate and very, very precise. They were thinking of lagging the gearbox, which would have caused temperature problems, etc., etc. Same installation on the offsite, there is 30 and 27 hertz tone, which is annoying the neighbors. This was diagnosed due to a pressure drop across the valve. Again, it had been suggested to replace with a quiet valve, very expensive, or to lag a massive amount of pipe. Now, as an engineer, I don't like lagging things because you trap moisture and that causes corrosion and makes inspection difficult. We worked out that the best solution would be to reduce the pressure drop across the valve by a few simple retrofit modifications, which got rid of the problem very cheaply, very quickly, and very easily during the next maintenance down time. Vibration is often very closely linked to noise. With fans, you have a direct excitation of the air, but with things like gearboxes, motors, pumps, etc., 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 you're causing vibration. These are large water pumps, and in this case, it was a vibration problem causing cracking. So damping, this is dynamic vibration absorbers. You can just see it moving. Those were retrospectively bolted on, completely killed the vibration. It's like judo, you're using the vibration against itself. This is one we designed for pipe work, which is again causing cracking. But we use a similar technology for high frequency noise. And if you have high frequency noise in addition, you can create a lamina in situ. And some examples of that, this is transformer noise. So looking at the noise from transformers, they do get hot. So they do need cooling. And you go, okay, I don't want to put an enclosure around it because that's going to cause cooling problems. I don't want to put a barrier next to it, is also going to cause cooling problems. And it has to be an enormously expensive and large barrier because of, generally speaking, it's low frequency plus harmonics. So in this particular case, vibration analysis, the base plate was the major noise source plus other panels that were radiating high levels of noise. This introducing lamination on the base plate reduced the vibration of the base plate by 93%, which had a similar knock-on effect on noise. And you can see these panels also are just vibration damped in situ. So this had dramatic noise reductions based on accurate diagnosis. And if you're looking at cladding, sometimes you do need to clad. This is cladding, an enhanced version of cladding, because instead of using standard aluminium or steel, or whatever you're using, it is laminated. This makes it very, very tolerant of any short circuits. And again, the thing is diagnosis. If you get a lot of broadband noise, it's not too difficult, but if you've got tonal noise off pipework from a compressor, for example, you get standing waves, very difficult to say where all the noise is coming from. You do vibration measurements, so you can work out exactly how much noise is coming from each part of the pipework. And then you can work out exactly what is the minimum area of pipework I need to damp or to lag to get the end result we need. So in this particular case, 16 to 19 dBA noise reduction. This is a process plant. The noise level in the area, well over 90 dBA. On average, it was over 90 dBA. But you walk around here, very, very tonal. So listening to that, walking around there, you go, okay, there's amplitude modulation, means there are at least two noise sources, probably two. The second thing is the noise level, 90 dBA, just over 90 dBA average, but in some places it's nearly 100, in other places it's only 85. And those two levels can be only half a meter apart because of what are called standing waves, which is reflections. And due to that, you cannot tell by ear where the noise is coming from. The analysis, This is the sound pressure level against time. You can see the modulation. That tells us there are two sources. Narrowband frequency analysis, 398 Hertz blade pass, which matches these fans. If you zoom in on the blade pass, you can see it's actually the two fans running at very, very slightly different speeds because of different loads. And then you can say, okay, aerodynamic noise control will cut the tones by 20 dB and completely solve the problem. The dreaded steam leak, 122 dBA plus, even double PPE, not safe. Maintenance is an issue, that's obviously, but you can do temporary lagging with things like these waterproof mobile screens. 20 to 30 dB off makes it much, much safer. These are steam traps across the site, lots of different steam traps, 105 dBA, very low cost steam trap modification, knock at least 20 dB off and then be copied across all of them on a site. This one. Okay, which bits of kit are the problem? Analyze it. You can see the tones. You say, well, which fan or blower has a blade pass frequency of that and harmonics? Aerodynamic modifications will kill that dead without any modifications to the externals. If we're looking at the sort of modifications we're talking about, fan speed, the first thing that we do looking at anything to do with blowers or fans is, can we make it more efficient? Because fan noise is proportional to the fifth power of fan speed, which means a small reduction in fan speed or improvement in fan efficiency has a massive effect on noise. So a 20% reduction in fan speed reduces risk by a factor of 3. 50% reduction in fan speed, you can dream, reduces the risk by 15 dB, which is a factor of 30. So these are cooling tower noise control based on the same approach. We've developed some very innovative modifications. These things are 7 meters in diameter. You cannot fit a silencer on them. 8% improved efficiency. You can run the fans at lower speed for the same flow with reduced wear. 6 to 10 dB noise reduction. Retrofit gearbox modifications, another 5 to 10 dB off the gear noise. So again, this is engineering approach based on good diagnosis. This is the largest biomass power station in the States. They contacted us because they'd had a conventional silencer fitted, which reduced their fan efficiency by 20%. So they had to take it off. They were desperate. So this is what it sounded like before and after treatment. So the annoying hum has been dramatically cut. And the thing that impressed me most about this was they did the whole, this fan is the size of a house. They did it in 12 hours shutdown. And it actually reduced power consumption compared with a naked fan. That's not counting the 20% they had with the silencer previously. This is a really odd one. I just like it because I'm a bit weird. These are boiler burners, 3 of these. A consultant said you need to turn your boiler house into a bunker at eye-watering expense, hundreds of K. My colleague went along and said, I think it's mixing problem. Have you got a yogurt pot? So they went to the canteen, ate a yogurt. He then modified the yogurt pot like a la Blue Peter, fitted it onto the spare unit, which was down, problem solved. So they just run these 3 with aluminium yogurt pots, cut down yogurt pots installed. Basically improved the mix of the gas air mixing and slightly improved the burner efficiency too. Oh, blackcurrant, by the way. So this is a BP refinery. This is the one I talked about, $1 million saved. So the local consultant sent us the data, sent us some noise files, sent us the details of the fans, aerodynamic modifications, killed the problem dead, saved them $1 million out of a $1.25 million quote for conventional approach. And we do this all around the world. We have a massive, massive database of engineering solutions. So we've come across most problems in some form or other. So people will send us the videos, and we will take a quick look, run it through our database and say, yes, there are options. I have been doing this for years. I set up INVC 40 years ago. I can walk through any site pretty well, point at a bit of plant, go easy solution, easy solution, easy solution. I need to study that one that's a bit different. That one, you are doomed. You have to have an enclosure. If you can't fit an enclosure, then there's no options. You have to use PPE. And I will give you a "you are doomed" certificate to say you can use PPE in perpetuity. So initially this is a free service that we offer anywhere in the world. The same applies to purchasing policy. There's no point in reducing noise on sites if you then buy very noisy kit. And the key takeaway is, don't allow your suppliers to spend your money on noise control without close scrutiny. You want to see what diagnostic process they went through. If they haven't got that documented, they have guessed. They are spending your money on things that are not best practice. They are buying stuff in, marking it up and selling it on to you. Most suppliers have no technical expertise in noise, or very little. If you're looking at big sites and planning for things like data centers, things like petrochem installations and so on, you do all the modeling and stuff, but it's all based on not enough information from suppliers. Some of it's based on guesswork, and almost none of it is based on engineering noise control options. So this is a 600 horsepower water pumps. Purchasing policy said less than 85 at 1 meter. It was over 95. The motor supplier blamed the pump supplier, who blamed the motor supplier, and this was going legal. They sent us that video. We did the diagnosis and said it's the thin panels radiating electromagnetic vibration. Damp those, 12 dBA off, no effect on anything. Solve the problem very, very quickly and easily. Now, the Control of Noise at Work regulations say thou shalt not use PPE long term unless you can prove that you can't cut the risk by other measures. That is almost universally ignored. So it's a regulatory requirement to carry out a noise control audit to say, what are my noise control options and what would the cost be and what would the risk reduction be? So then you can make a sensible decisions about risk reduction programs. This approach is easy to train engineers. You can use an app, and there's some knowledge about materials and the diagnostic system. So once you've got your noise control audit, which tells you what your options are and what the costs would be and what the likely risk reductions would be, noise reductions would be, you can then plan and implement the best options. And even where you can't get below 85 or 80, you're still reducing the risk so the PPE is more effective, and the HSE will love that. And if you can get below 80 or 85, then you revise your PPE requirements. And the same thing needs to be implemented in the purchasing policy. You need documentation and training for procurement, and make sure suppliers have done the diagnostics, and they won't have. And police it. Police the policy, because it's going to cost you money if they introduce new noise hazards into your site. So I have never come across a company who've actually done a proper return on investment as far as noise is concerned. So here are the things you need to think about. What's the actual daily wear rate in noise hazard zones? What's the actual employee field protection you're getting? Not 20 to 30 dB, probably only 3 to 10 dB. You need to know that. You need to know wear rates, unless you're using the very new, what we call intelligent PPE, which automatically measures that. And how much do you spend on PPE and risk management per annum on average? Virtually nobody knows that. That's one figure. You can do the likely real world protection from by joining this program, because we will be supplying a tool to do that. Secondly, noise assessment and health surveillance. You do need reports that include an action plan that includes noise control. Most reports are fairly poor quality and largely placebo reports that tell you what you already know, that you do have a problem and it's exactly this big, and nothing on noise control or very little. So how much do you spend on that and audiometry? You need to switch from conventional audiometry to otoacoustic emission, which will give you feedback within a year if someone's getting damage. And ultimately, you need to carry out noise control audits to say what would be the cost of noise control and what would consequences be. And you're including sustainability impact on noise control measures. In other words, embodied carbon. You need to know what your return on investment is going to be. There are a whole load of links on the presentation that will be sent through to give you more information. So summarizing, we're looking at the attitude to noise control, which I talked about. And you can't depend on noise consultants, very sadly, because their knowledge of modern noise control and diagnosis is awful. The assumptions, it's not just enclosures and things. So you need to change. The biggest problem is the assumptions about how difficult noise control is and how costly it's going to be and how much hassle. That is not necessarily true. So, finalizing, big impact on costs coming down the line, already happening. HC noise inspections, illegal changes, and the massive increase in risk posed by to dementia, etc., which has been identified by recent research. So this health costs, huge claims and insurance. The good news is, so that's the bad news, if you like. The good news is, by implementing best practice in reporting audiometry and noise control, you can reduce noise-induced hearing loss by between 75 and 90% at negligible or no cost compared with current practice. And noise control is a very key element of that. So looking at the risk and Greenpeace dividend, most noise control projects, by using a diagnostic approach, you can reduce the cost by 50 to 80% and reduce the carbon footprint involved using modern technology. It's long past time to change. I find it just so depressing. In the 40 years, go to most sites, nothing much has changed. And yet the technology has moved on. As I say, from narrowband analyzer at the cost of a car to something you can do for free on an app. So the Noise Project, information request is a summary of some of the things. We're looking for people to join the project. So we're looking for, if you've got copies of recent risk assessment reports, anything about PPE use, programs, documentation, problems, solutions, current noise issues, including descriptions, photos, smartphone video clips, NDAs, no problem. We will be selecting a few organizations joining this for remote control of noise diagnosis, which I've demonstrated now. That's a very quick, simple way to solve sort of urgent noise problems. And we will also be selecting a small number of sites for a free site visit. Well, when I say free, it means the Energy Institute is footing the bill for the site visits. So effectively, you're getting a big chunk of free consultancy about what would be best practice on your particular site, on your particular noise problems. So that is quite a carrot. Plus, we're asking also information on problems you've had with previous noise control projects or current noise control projects. You know, we see blowers with enclosures, and half the enclosures have been left off because it's overheating and it makes maintenance difficult. And if you have by quiet documentation, some or all of this very, very useful, free to add anything else. All the information will be anonymized and not attributable to anybody unless you decide you'd like it to be attributable. So the benefits: access to the guidance for people who participate in this, fill in the forms and so on, plus the PPE tool, plus we'll be developing webinars which will be demonstrating some of this stuff with case studies, etc. So how to reduce hearing damage risk within your organizations by 75 to 90% within current budgets pretty well. This isn't just noise control. This is also some of the other things, reference to some of the other things that can be done as well. This also applies to environmental noise. And we will be undertaking a number of site visits to do a detailed evaluation, full-on evaluation. But there is a sort of limited availability of cost for that. So it's a bit of first come, first served. And if you want to be acknowledged, and this is quite good for PR with the HSE, is, you know, we have a very successful proactive noise control project. The HSE will be very, very interested. So those are the email contacts, and Laszlo will be forwarding copy of this presentation and other things, other information onto everyone sending this, and you can then decide, I'd like to be part of this, I'd like those benefits. Any questions?
Thank you, Peter. We've got one question from
Yeah.
Chris Steele. He's an HSE inspector.
Hello,
for
Chris.
Northern. Oh, you know Chris. I know
Yes, I
Chris,
do.
actually. So the question is about what we would like to comment on your comments about hearing tests. I'm not sure what those comments are. See, Chris, are you putting these in the chat in the Q&A function, or do you plan to comment on them offline?
I can sort of imagine part of it is that conventional audiometry is not a risk management tool, and that's what I'm very concerned with, is risk management. It tells you after the event, a bit late, that someone's got damage, and whereas otoacoustic emission can tell the very early stages of damage. So it's a useful risk reduction tool along with noise control and proper use of PPE and so on. Any other questions?
So I've got one, Peter. Sorry, but I missed
Go on
the.
then.
I think maybe I'm alone with this, but I missed the solution to the sellotape issue because the video was a bit laggy. So can you tell us how you solve that
you
issue?
can buy a quiet tape, so when you pull it off the roll,
Oh.
it doesn't make any noise.
So
I
it
may
was
be
just
very
quiet
sad, but
tape,
I just thought that was brilliant. But if you know that it's
Yeah, okay,
available,
so-
you can solve the problems. The point is that if you know what techniques and technology and things are available, then it makes a big difference. And the same applies to pneumatic noise, for example. You can buy off-the-shelf nozzles that use 20% less compressed air and are 90% less risk. So you have to know about it. And unfortunately,
Okay.
knowledge is somewhat limited.
Yeah, it kind of blows my mind that sometimes the solution is really simple, yet companies go for the typical off-the-shelf, expensive off-the-shelf solutions, and there are in many cases even less effective than some of the more cost-effective ones. So yes, Chris was I think Chris was trying to make comments. Was trying to speak to us, but just as a reminder, we've muted all the participants. So I just asked Chris to post his comments in the Q&A function, the Q&A box. Any other comments?
Sort of hearing a deafening silence.
I was going to say, I'm hoping that no one has suffered hearing damage watching your presentation, Peter. Some of
That would be the ultimate irony.
That would be ironic, yeah. Yeah, some of the noise from those equipment were quite loud. Don't see any more comments, so maybe this is something to follow up with Chris offline.
Yeah.
And oh, there is a new post, sorry. So he says that the HSE does expect pure tone audiology. So while other hearing tests are available, HSE inspectors will be looking for pure tone audiology results, and this forms part of the expectations around health surveillance. It also ties in with other government expectations for providing disablement benefit.
Yeah, I mean, pure tone audiometry fits in with all those things, but My concern is with a risk management tool, which pure tone audiometry can't really do. It's too slow and too late, and doesn't pick up all the forms of damage. The advantage of OAE is that you can use it on an annual basis, perhaps in addition to pure tone audiometry, as a risk management tool. You can say, last year you had 12% damage, this year you've got 18% damage, let's do something about it. Whereas pure tone audiometry would tell you 10 years later, sorry, you've got hearing damage.
Right.
It's as a risk management tool that the big benefit is.
We've got one in the chat one. It's just Tom Halgate, just thanking you for the presentation. Very informative. Well,
there's also return on investment, guidance on the cost of preventing different levels of hearing loss. This is down to claims, and this is going to dramatically change. If claims are going to go up, it looks like, based on just what's happened, from like 5 to 15 or 50k to maybe 700k in certain cases. So suddenly the cost is just going to jump by an order of magnitude or two. So it does depend on the circumstances. And this is still early days as far as the research is concerned and the revised legal framework.
Right. Well, thanks for the Alex.
So you know that cost is going through the roof.
Right.
And as a matter of course as well, anyone got any delayed questions, then feel free to email us, and I'll get back to them. I'll get back to you as and when, as soon as. So and also the presentation, Laszlo, you're sending out the presentation to everybody as well.
Right. You? We have a bit of an editing to do on on those, but in about 2 weeks, we should be able to upload video to YouTube, and then we will send out the link to the video,
but also the PDF of the presentation. The PDF of the presentation.
Presentations, yeah. And I want to ask you about that, Peter, because obviously your slides have lots of embedded videos and sound files.
Well, so the PDF has not got the sound files and things, but it's got all the links. So it's got links to lots of resources on HSE website and various other websites as well as ours. Which a lot of that has got sound and links to videos and various other things. So
great. So if anyone's
you can go via the links in the PDF.
Great. Okay. Thank you.
Including a brilliant video from the HSE about the performance of hearing protection.
Right. Okay, great. So we've got one more. Where can we find your contact details if we want to reach out? So they are in the presentation slide.
Yeah, so if you send out the PDF as soon as, and also just contact Laszlo or me or INVC
direct. Amy, my colleague, just dropped my email to the chat, to the Q&A box. So feel free to email me, please. So both slides will be available shortly after the webinar. And we are 2 minutes over, actually. Are we? Is there anything else, Peter, or shall we?
I think, unless anyone's got any questions, that's.
Don't see any more coming in.
So delayed questions, just send an email, and we'll answer them after the event.
Well, that leaves me with saying thank you very much, Peter. It was such a great presentation. Lots of great examples. The yogurt part was my personal favorite. And thank you everyone else on the call for joining. And so we'll keep in touch with any development in this project, and we'll let you know once the recording is ready, and we'll send out the slides. So thanks everyone, and have a good rest of the day.
Take care. Cheers.
Bye-bye.